We had to make a few assumptions while modeling this scenario. First, we decided to keep a constant exchange rate because we were only modeling 5 business days. If we were to take this model and expand it over the course of a year or 5 years, etc., we would need to take into account the change in exchange rate because that could drastically affect profits. Second, we decided to assume that each day the client had the same percentage of different transaction types. For example, customer 17 will have the same percentage of euro to dollar transactions on day 1 as they do on day 3. Lastly, we decided to use the average transaction amount per transaction type as a transaction size. Here we have SafeBank. We have 6 different servers representing the different types of transaction types, for example, euros to pounds, euros to dollars, etc. Each of these servers has a processing time of 0 because these transactions happen instantaneously. We also have 30 entities representing the 30 clients that do business with SafeBank. Here is where our swap with Global Bank occurs. This can occur at any point throughout the day when our inventory levels reach below a certain reorder point. Each of these syncs represents the 3 different types of currencies. When the respective currency drops below the reorder point, an event is triggered and the money is released. It takes about 30 minutes from the trigger to happen to it getting back into the inventory. Only one swap of each currency is allowed at a certain time, so these initial capacities are 1. Here is where the logic behind our swap process happens. Where you see purple, that is euros being swapped. Where you see yellow, that is pounds. And when you see green, that is USD. The first part of this process is to decide if other currencies have available cash to be able to be swapped. Whichever has more gets swapped according to the amount needed as well with the conversion exchange rate. This last step here counts the 5.5% of the transaction that it cost to have this midday swap. Here we have the process for the end of day swap with CLS. The first thing this process does is calculates the difference in values from 6:30 p.m. when the day ended and when the day started at 8 a.m. It then decides based on the currency type, this is the euro process, this is the GBP process, and this is the dollar process, if that currency needs to be replenished. If it does not, the process ends and moves on to the next one. If it does need to be replenished, first it checks the other currencies to determine if there is available currency to be transferred. If there is available currency, they then decide if it's sufficient to settle the entire need of the original currency, or if they need to go back to the other currency. So if there is, for example, if there is enough dollars to settle the euros, it will assign the dollars to the euros and then end. If there is not enough dollars to settle the euros, then it will give what it can and then go to the pounds and take the available pounds and convert those to euros. It repeats this for both the GBP and the USD. This is the process we have for the servers during the transactions. It first takes the input currency and adds that value to our inventory. It then takes the desired currency and subtracts that value along with the rate. Also at this step, we take the 0.02% of transaction and add it to our profit. To determine the best operational policy for SafeBank, the revenue, cost, profit, and number of customers served were compared for 5 scenarios. The original model setup, business as usual with predetermined initial currency values, when the euros default, when SafeBank loses the option to swap with Global Bank, and a change in policy with CLS. In conclusion, we determined that the optimum values for the cash on hand to start each day should be $14 billion, 8 billion euros, and 5 billion pounds. Moreover, the swap policy with Global Bank has to be established using the model. The ideal trigger point for each type of currency was found to be $5 billion, 3 billion euros, and 2 billion pounds. The swap amount, or as we call it in our model, order quantity, was also found to be $10 billion, 5 billion euros, and 5 billion pounds. The business as usual model starts each day with a high initial inventory. However, the bank can run at a sustainable level without having to keep so much of each type in hand. The high starting value requires swapping currency at the end of each day, and having a higher starting point requires more money to be moved. Consequently, more money is spent paying for the swaps. Therefore, it is more efficient to have a lower starting value. For the end-of-day settlement policy scenario, the simulation was run for 30 days, and the CLS transaction did not have to occur at the end of every day. To maximize profits for the bank, it was determined that $14 billion, 8 billion euros, and 5 billion pounds were the optimum values. Overall, we came to the conclusion that the best scenario we recommend SafeBank use in terms of optimizing the profit was the loss of counterparty scenario. This conclusion is based on the scenario having high revenue and profit and a low cost. The cost is low for this scenario because there is no swapping, and that is a very expensive process that occurs throughout the day. The revenue for loss of counterparty scenario was $796,100,008.92. The cost for the scenario was $24,278,242.01. The total profit was $771,821,766.90. Overall, an excellent profit for the 5 days we recorded.